Every year, patients undergo surgeries expecting safety, but sometimes preventable serious mistakes happen. These are called never events because they should never occur. Today we're breaking down a fascinating study that used machine learning to uncover hidden risk factors behind surgical never events, things like wrong site surgeries and retained foreign items. But before proceeding to explaining the article, what is a never event? Never events are serious incidents that are wholly preventable because guidance or safety recommendations that provide strong systemic protective barriers are available at a national level and should have been implemented by all healthcare providers. Examples of two major types of never events are wrong site surgery and retained foreign objects. Wrong site surgery refers to an invasive procedure performed on the wrong patient or at the wrong site. The incident is detected at any time after the start of the procedure, for example, a wrong site block, including blocks of pain relief and line insertion. Procedures excluded from this definition are removal of wrong teeth, local anesthetic blocks for dental procedures, interventions where the wrong site is selected because the patient has unknown or unexpected anatomical abnormalities. These should be documented in the patient's notes. Wrong level spinal surgery, wrong site surgery due to incorrect laboratory results, or incorrect referral letters, contraceptive hormone implant in the wrong arm. Retained foreign objects refer to the finding of a foreign object in a patient after a surgical invasive procedure. Foreign object includes any item subject to a formal counting or checking process at the start of the procedure and before its completion, such as for swabs, needles, instruments, and guide wires. It's important to explain why these never events persist despite the vigorous perioperative checklists. Human factors are the physical, cognitive, and social elements that influence how people work. It shapes how safely staff perform tasks, and it impacts decision-making, attention, and teamwork. Poor human factor design increases the risk of never events. Breakdowns in how information is shared. Unclear, incomplete, or incorrect communication. This leads to errors in surgical counting, mitigation, or site verification, and causes misunderstanding between theater team members. Also leads to an increased risk during handovers and time-critical moments. High workload, time pressure, staffing shortages, or fatigue affecting performance, reduces concentration and situational awareness, increases likelihood of skipping safety steps, such as the checklist items, contributes to stress-related mistakes, and reduces team performance. So let's start with how the researchers collected their data, because this is the foundation of the entire study. They used two types of samples. Over 9,234 surgeries were observed in real time across 29 hospitals. Trained observers, medical students, nurses, and physicians watched surgeries and recorded 93 different features for each one. These features included things like, was the surgical count correct? How many nurses were present? Was the timeout checklist completed? How long did the surgery last? Root cause analysis is another method of sampling in this study. Let's go over what it actually means. Root cause analysis is a detailed investigation that hospitals perform after a serious error occurs. In the context of this study, root cause analysis is a structured review that tries to answer what went wrong, why did it happen, which steps failed, which safety checks were missed. This led to the collection of 101 root cause analysis from the never events, which were 49 wrong site surgeries and 52 retained foreign items. Each root cause analysis was manually annotated by the authors using the same 93 features used for the normal surgery observations. There is a challenge to the root cause analysis because it's done retrospectively and often doesn't include every detail. For example, if the event was retained item, the root cause analysis might not document timeout checklist steps. This led to up to 40% of missing data in some features. To fix this, the researchers used iterative imputation, where a decision tree model predicts missing values based on the rest of the data. It's important to note that without the model, we would only see normal surgeries and wouldn't know what distinguishes them from errors. Now let's talk about how they actually analyzed all this data. They used a machine learning technique called a random forest. If you're not familiar with it, here's the idea put in simple words. A random forest builds many small decision trees, each one making simple yes and no decisions. Examples of such could be, was the surgery shorter than 1 hour? Yes or no? Was the timeout checklist completed with all staff present? Yes or no? Then it combines all these trees to make a more accurate prediction. One of the pre-processing steps they had to do to prepare the data was to build 3 separate models of normal versus all never events, normal versus wrong site, normal versus retained items. They evaluated the models using 10-fold cross-validation, achieving AUC scores between 0.81 and 0.85. And if you're someone who isn't familiar with the AUC score, just know that this is considered an excellent score as it shows that it models separate classes across thresholds mostly accurately. Now, if you're wondering how machine learning actually works in this context, here's the simplest way to think about it. Imagine you're teaching a child to recognize cats. You don't give them a rulebook. You just show them loads of pictures of cats and loads of pictures of non-cats. Over time, they learn the pattern: pointy ears, whiskers, and tail, and they can identify a cat they've never seen before. Machine learning works the same way. In this study, the pictures were 9,234 normal surgeries, 101 never events, each described by 93 features. The computer looks for patterns humans might miss, especially combinations of features that increase risk. And the patterns it found were surprising. Some features massively increase the probability of a never event. Discrepancy in the second surgical count up to 1,950% increase. Surgery paused due to a count discrepancy up to 1,540% increase. Surgery lasting less than 1 hour, higher risk for both wrong site and retained items. Some features decrease the risk. Surgeon scans the cavity before closure up to 100%. Team agreement during timeout up to 100%. Second count performed before closure reduced risk in multiple departments. Certain pairs of features produced huge jumps in risk. In general surgery, some combinations increased risk by 13,600%. In orthopedics, between 1,825 to 4,225%. In urology, 1,900 to 2,600%. These combinations were rare, but when they happened together, the risk skyrocketed. Shared risk factors for both types of never events. The model found 3 overlapping predictors. When 2 nurses were present, wrong site surgery increased by 66%, and retained foreign objects increased by 88%. When the surgery lasted less than an hour, wrong site surgery risk increased by 122%, and retained foreign objects increased by 87%. When the surgery lasted between 1 and 2 hours, lowered risk was noted for both types of never events. So, what does all of this tell us? It shows that surgical safety isn't just about following a checklist, it's about understanding how different factors interact: staff composition, timing, workflow, communication, and even the length of the surgery. The authors conclude that safety protocols should be tailored to the characteristics of each surgery, not applied as a one-size-fits-all solution. And remember, this is educational only, not medical advice. Here is additional literature you may want to look into for extra guidance and knowledge. The resources used in this video will be given a link to in the description below this video.